so as a warm-up today, let's pick a radius and let's pick an angle. What? No, we're gonna do it. Then we all get the same one. Okay. 4. I like 4. Okay, so 4 is our radius. Okay. 4 is the radius, and then let's go with. I don't like it. I don't want something on a ray.
285.
I don't want something on a ray. So, like, can we go with, like, 37.5? Yeah. Okay, let's do it. All right, let's make it even easier. Let's go 40. Okay? We'll make it even easier. We'll go 40 degrees. So that is the point, okay, in polar coordinates that I would like you to plot, and I would like you to rename in 3 different ways. So 40 degrees is kind of, so 15, 30, so 40 degrees is kind of like through here, right? Right? Okay, so that's my 40 degree line. Okay, so the negative of that one would be what? Negative 320. So another way to rename this point would be 4, negative 320 degrees. Yes? Like it. Love it. Can't get enough of it. Okay. Then we'll go it that way. Coming through down here. So how can I quickly find the positive of this gold one? Add 180 to my degree, right? Okay. So this would be like 220 degrees, right? Okay. And that would be a negative then of? Oh, I'm sorry. Yes. Okay, I got you. You guys are saying, so this would be negative 4, 220 degrees. Okay. What would the negative angle associated with 220 be? Negative what? Negative 140 degrees. Yep. And so then the third one would be negative 4, negative 140 degrees. You know what we never did? Never actually plotted the point. Yep. But now I plotted it. Okay? Okay. So, what we are going to do today is we are going to figure out how to convert from polar to rectangular and from rectangular to polar. Now, in your purple packets, this would be on the converting points page, which is the first blank page on there. Okay? So, what we first need to do is remember that polar is r comma theta, and we want to convert that back and forth into x comma y. So that's what we're talking about today. R comma theta and x comma y, going back and forth between the two. Okay? So we should, let's just pick a point right there. Okay? We can put it anywhere really, but let's put it in quadrant 1, then everything is positive for us. Okay? So that point there has an x and a y value if it's in rectangular, and it has an r and a theta if it's in polar, right? Okay. Well, let's go rectangular let's go rectangular first, into polar. Okay? So that point, that x comma y point, how am I going to be able to find the r and the theta of that exact same point? Okay. Okay, so I could make a triangle out of it. So I can make a triangle out of it, right? And then this is my x, and that is my y. So then you're saying that I can do a Pythagorean theorem action on it, okay? So r would be there. So r is going to equal the square root of x squared plus y squared. Right? I'm good with that. Where have we seen that before? See if we come up with the next one. All right, so theta. What about theta? Kevin? But is that going to give me my actual theta? In quadrant 1, yeah, but what are we always going to be in quadrant 1? No. So what really are we finding? We're really finding a reference angle, yeah. Theta prime, remember. Okay? And so because of that, we've got two conditions. Condition number 1 is we're going to drop any negative signs. Condition number 2 is we're going to, how did I say it over here? We're going to check our quadrants too. Okay? Because if I'm in quadrant 2, I have to subtract my reference angle from 180 degrees. If I'm in quadrant 3, I've got to add my reference angle to 180 degrees. If I'm in quadrant 4, I've got to subtract it from 360 degrees. Okay? So we've got that going on there too. Okay? So that information right there is what should go into your toolbox at the top of your page, because that's going to be a quick reference guide of, oh yeah, I got to do this if I am switching from rectangular to polar. Okay? Now, while you're copying that, let's go the other way. So now we are in rectangular. Oops, taps the brakes. I wrote that wrong. Now we are in polar. And I want to go to rectangular. So now I have the distance that I am away from the pole, and I have the angle that I'm at. How am I going to find the x part and the y part of my rectangular point? Think about the triangle again.
Use sine, cosine.
Which one which?
Cosine. Sine.
And that would work if I was always at a distance of 1 from my pole, right? Because that's unit circle stuff, right? X is cosine of theta, y is sine of theta. Okay? if I'm a distance of 1? Am I always going to be a distance of 1? So how can I bring that I'm not at a distance of 1 into it? You've actually seen it before. We just did a whole unit on it. So x would be what? So x here is r cosine of theta, and y is r sine of theta. The nice thing about going from polar to rectangular is it's all right there for you. You just type in your r, you type in your theta, and you're good to go. Okay? Alright? If it's that whole going from rectangular into polar where you got to check everything. But yeah, going into rectangular from polar, much, much easier. Okay? Let's try some. So, the first thing that you have to determine is you're going to have to determine for yourself what form you're in. Okay? So, 3 comma pi over 2. Which form is that in? That's polar because pi over 2 is an angle. Right? Okay? Now, just out of, if I had the whole, let me see if I can. If I had the whole, there you go, 3 of them. Right? Where would this point 3 comma pi over 2 be? Straight up, right? Straight up from the pole, it would be right there. Yes? So really, in rectangular, it should be 0 comma 3. Right? Let's verify that now. Okay? So x here is going to equal 3 cosine of theta, because remember x is r cosine of theta. Cosine of, oops, taps the brakes. Let me just start over again. X is r cosine of theta, so that's going to be 3 times the cosine of pi over 2. What is the cosine of pi over 2? 0. So this is 3 times 0, which is 0. Okay? And then y is going to be r sine of theta. So that's going to be 3 times the sine at pi over 2. What's the sine of pi over 2? 1. 3 times 1 is 3. So the answer here is 0 comma 3. Yeah?
We put it in degree, like just put it as 90, but then have the degree symbol on it.
So how we type it in on our calculator makes a difference, right? Okay? If your calculator's in degrees and you type in the cosine of pi over 2, you're not going to get 0. Okay? So you got to pay attention, yes, on the mode of your calculator. Now, we want you to be as exact as possible. So if we give you a unit circle angle, I want you to give me a unit circle value coming back. Okay? All right? If I don't give you a unit circle angle, then you can be as exact as possible by rounding. But if it's one of the sweet 16, we want it exactly. Okay? Please try letter B. So we got x is r cosine theta, so that's going to be 3 times the cosine of pi over 6. The cosine at pi over 6 is square root of 3 over 2. And then 3 times the sine at pi over 6. So that's going to be 3 times 1/2. That gives me a point exactly here at 3 square roots of 3 over 2, comma, 3 over 2. Yes? Questions on that? All right, let's try. Whoa, that kind of jumped on me. Let's try these two. So now we're in rectangular. Let's go to polar. Yes, sir. So going the other way, we want r is going to equal the square root of x squared plus y squared, which is going to be the square root of 3 squared plus 1 squared. And then we're going to take the square root of that. Okay? Square root of 3 squared. 3, 1 squared. 1, 3 plus 1 is 4. So this is the square root of 4, which is just 2. So my r value is 2. Right? Okay? Which quadrant is the point, the rectangular point, the square root of 3, comma 1 in? It's in the first quadrant, right? So reference angle is my actual angle in quadrant 1. So theta here is going to be the inverse tangent of 1 over the square root of 3. Inverse tangent of 1 over the square root of 3 is degree measure or radian measure? 30 degrees. So I could write this polar point as 2, 30 degrees, or I could write it as 2, pi over 6 radians. You would only have to write it one of those ways, depending upon which way you did it. If you did it in radians or if you did it in degrees.
Like ask us for one, like have answer in radians.
If it would be in the directions if we had it that way. Mm-hmm. Okay? You try letter D now. Equal the square root of x squared plus y squared. So that is negative 2 squared plus 2 squared, and then we got the square root thereof. So that is going to be 4 plus 4, so that is the square root of 8. So exactly I would leave that as 2 square roots of 2. Okay. Which quadrant am I in? I'm in quadrant 2. So theta prime here is going to be the inverse tangent of 2 over 2, which is 1. So the inverse tangent of 1 is 45 degrees. So my actual theta is because I'm in quadrant 2, that's going to be 180 minus theta prime. So that's going to be 135 degrees. So that gives me 2 square roots of 2, 135 degrees as the degree measure of that polar point, or 2 square roots of 2, comma, 3 pi over 4 as the radian of that point. Questions on that? Oh, it went too far. Try those two, please. There will be another video with the answers to these two problems posted right after this current video. So if you wanted to check out the work, do that.